So here at the NeoGenomics lab, we have to carefully control the airflow in all of the spaces. So we have supply air valves, return air valves, and exhaust air valves so that everything can always be balanced. The supply air valves are set to a specific CFM, and then the exhaust and return air valves are what control the balance. So we have an exhaust air valve on these hoods so that it always maintains 100 feet per minute face velocity. So as we open the sash, we've got a meter right here that's going to tell us the face velocity, and you'll see it dip, but it'll go back up as the valve opens. And as that valve opens, that talks to the return valve and lets it know that it has to close down. So as we open this sash, it's going to maintain 100 feet per minute. So that we don't pull this area negative, our return air valves will start to close. So we're always maintaining a balance in this area, as well as the face velocity on the hoods. And then we also have a purge mode that'll just open the exhaust valve wide open, so that if there's anything built up in here, it just gets purged out. As well as alarms. We have alarms on here so that if the face velocity drops too much, it'll alarm, let them know they should stop working in this area, close the sash, and that's it. Okay, so this is our bank of VFDs for our exhaust fans. So we have a total of 5 groups of exhaust fans. They're all the high plume exhaust fans. That's what is exhausting the lab area. So all of those are high plume. They're meant to run at a certain speed, so they actually discharge the air up to a certain distance. These are all N+1. So you'll notice we have LEF1A, LEF1B. So under normal circumstances, we're only going to run one of these at a time. Every week we'll swap, so it's a lead lag system. But if they ever lose one, because they're dealing with a lot of chemicals and the exhausting is something they can't just lose out of nowhere. So if they ever lose a fan, say LEF1A for whatever reason kicks off, they kick on LEF1B automatically. And it's the same for all of these. So everything's N+1 for the second fan. For fan 2, we have A, B, and C, because at any given time, it takes 2 fans to get the CFM that we need. If we ever lose one fan, we kick on another one. Same for each one of these. These are all being controlled at a set speed all the time. And then we have bypass dampers on the roof to control the static pressure. Normally we would adjust the fan speed, but because it's so important to discharge that air to a certain distance, we use the bypass dampers instead to control that static.